In this example, we can use the Gram-Schmidt procedure to find an orthonormal basis. So let's start by finding our vector E1. E1 is just a normalized version of U1. So here we've got the length of 1 over the length of U1 times U1. Now the length of U1 here is 1, 2, 3, 4. So 1 over root of 4, so that's a half, times 1, 1, 1, 1. Now we need to see the projection of U2 onto E1. Projection onto E1 of U2 is going to be U2 dot E1 over length of E1 squared times E1. Need to put a half in there somewhere. Okay. So we've got U2 dot E1. So there's going to be a 1/2 that pops out front, but essentially we've got 1 plus 1 minus 1 minus 1. And so we've got that dot product as 0. So the projection of U2 onto E1 is 0. So because these two vectors are orthogonal, then we simply need to take our U2 and create our E2. So our E2 in this case is a normalized version of U2. So 1 over length of U2 times 1, 1, minus 1, minus 1. The length of this guy is root 4 or 2. So we have a half times 1, 1, minus 1, minus 1. Okay. Now that we've got our E1 and E2, we need to orthogonalize our U3 against E1 and E2. So we need to figure out the projection onto E1 of U3. So that's U3 E dot E1 over length of E1 squared times E1 and length of E1 squared is 1. We've got U1 dot E1 or U3 dot E1 is going to be 0 plus negative 1 plus 2 is positive 1 plus another 1 is positive 2. So we've got the dot product is 2 divided by 4 because of the coefficients in front of the E1s times our E1 our direction of E1. And so we get a half times 1, 1, 1, 1. Then we normalize against, or sorry, we orthogonalize against E2. So the projection of U3 onto E2 is going to be U3 dot E2, the length of E2 squared times E2. U3 dot E2 is going to be 0, minus 1, minus 3, minus 4. Divided by 4 times E2. So 1, 1, minus 1, minus 1. Until it's really just the negative of the vector. So minus 1, minus 1, 1, 1. Okay, so we've got the two vectors that we need to orthogonalize against. And so we end up with what we'll call W3 equals U3 minus this projection minus this projection. And so we get U3 is 0 minus a half plus 1 is plus 1/2. Then we get U3, which is negative 1 minus a half. So that's minus 3/2 plus 1. So that's minus a half. Then we get 2 minus a half is 1.5. Minus 1 is negative 1/2. Try that again. 2 minus a half is 3/2 minus another 1 is plus 1/2. And finally, we've got 1 minus a half, which gives us a positive a half, minus 1 is negative 1/2. So our orthonormal basis our first vector is 1/2, 1, 1, 1, 1. Our second vector is 1/2, 1, 1, negative 1, negative 1. And our final vector, which coincidentally actually came out in as a unit vector, so we can call this W3, we can call it E3 if we like. It's 1/2 times 1, negative 1, 1, negative 1. And so that's the orthonormal basis that we get from the Gram-Schmidt process for this example.